Hello viewers, welcome to this video. If you have been watching this series, congratulations. We are doing a fantastic job in terms of preparing for the quant section of the GRE, and I hope you're liking the content, the style and everything. If you have any suggestions, do feel to leave some comments. Even otherwise, if you would like to indulge in any sort of conversation, feel free to use the comment section. But I hope, again, I mentioned this in the last video also, I hope you have been solving the questions instead of just watching the video, because that's where the real value lies, right? If you're new to this video or this video series, what we are basically doing is we are going through the GRE Big Book Quant sections. There are going to be 54 such videos, and this is the 9th video. You'll find all the other videos in the description. I recommend that you go in a particular order so that your GRE preparation is comprehensive. On that note, let's get started. Okay, so we have Big Book Test 5, Section 3, 30 minutes, 30 questions. Let's get started. Question 1. A man left 1/3 of his estate to his widow and designated that the remainder be divided equally among 4 of his sons. Okay, so how is this happening? 1/3 to the widow, so we'll have to pick a number that is a multiple of 3. Let's say he had $300, so he left $100 to his widow, so he has $200 left for sons. How many sons? 4 sons. Okay, so each son is going to get 50, 50, 50, 50, right? And the widow rather is going to get 100. Okay, what do I have to compare? The fraction of the estate designated for each son. Each son is getting 50, which is out of the $300 of overall estate. So this fraction comes out to be 1 by 6. So this is 1 by 6, this is 1 by 12, right? Numerator is the same. We have denominator bigger here. That means this number is going to be smaller, correct? So answer choice A. You could also do it the other way. You can just purely use algebra. For example, how many, so 1/3 is given to the widow, so that means 2/3 left for sons, and each son, there are 4 sons, so each son is getting 1/4 of that, right? So what is this number? So this number is again 1 by 6, right? You would have got the same number, but answer here is A. Okay, question number 2, the sum of the areas of the shaded region. Okay, sum of the area of the unshaded region. Okay, the sum of the areas of the shaded regions. Okay, so I'm supposed to find out these 4 shaded regions, add them up and compare that with the unshaded region. Okay, what information do I have? M and PQ are midpoints of the sides of a rectangle. Okay, so this is a rectangle. I don't know the dimensions, so I'll have to assume some dimensions. Okay, and all these points are midpoints, so it makes it easy if I take 2a by 2b as a rectangle. So this will be b, this will be b, this will be b, this will be b, this will be a, this will be a, this will be a, this will be a. Okay, now I see that all these triangles are basically the same triangle. I mean, they are similar. One side is a, the other side is b, right? And the area of that is going to be half AB, correct? For each of those triangles. So overall, it's going to be, what is it going to be? It's going to be 4 such triangles, right? So 4 times half AB, so that's going to be 2AB. Okay, so 2AB is the sum of areas of the shaded regions, 2AB. All right, and areas of the unshaded region. Okay, what is the unshaded region area? Area of unshaded region is area of the overall triangle, which is 2a into 2b, which is going to be 4ab, that minus this shaded region area 2ab. So 4ab minus 2ab, again I get 2ab. Both quantities are equal. Answer choice C is the correct answer. Okay, you could have also done it intuitively because these are all midpoints, right? Just look at it this way. These are all midpoints. So this area, if I look at these lines are dividing the whole rectangle into 4 equal areas. Within each of those areas, right? This line is also dividing each area into one shaded region, one unshaded region. So essentially, if you add the shaded regions and if you add the unshaded regions, this is all going to be they are all going to be same in area, right? So that's how you could have done it intuitively also, right? But it's better to verify. Question number 3, root of 38,205. I don't know the root, but root of 400 I know. Root of 400 would be, what would be the root of 400? It would be 40, right? What 40,000, correct? I can write 200 as root of 40,000, right? So now I have to compare 38,205 with 40,000. Obviously, answer choice B is bigger. Both are positive numbers. Those are not numbers less than 1, right? Less than 1, the root and square roots uh, can be quite tricky, right? We have covered that point. What I'm basically saying is, if you have 0 and 1, if you have x here somewhere between 0 and 1, x square is going to be less than x, root x is going to be more than x. Whereas if you have x here which is greater than 1, x square is going to be bigger than x and root of x is going to be smaller than x. Okay, these are two different x's. Okay, right, but those kind of situations are not there because both these numbers are greater than 1. Okay. If one was greater, one was smaller, or both were smaller, then we would have gotten into some tricky area. We would have to evaluate. I don't think it's not going to make any difference there, because if both are smaller, then also they are all going to behave in the same fashion. So it's not going to change the answer as such, but that's a case that we have to be mindful of. Okay. So the answer here is going to be, which is the bigger number? Column B is the bigger number. Answer choice B. Okay. Uh, let's number 4. Sorry, question number 4. A, B, C are negative integers. Okay, negative integers. I can take some numbers. Let's say I take them as -1, -2, -3. Right. So what do I get here? ABC. ABC is -6. Correct. A into B plus C. So -1 into B plus C. B plus C is -5. I get 5 as an answer. 5 is bigger than -6. Answer choice B. More fundamentally, what you could have also done is look at this logic. See, all these are negative numbers, right? And this is a product of 3 negative numbers. So this is going to be negative. Whereas this is a product of only 2 negative numbers. A is negative, that we know. B plus C is also going to be negative because both B and C are negative. So this is negative into negative. This is going to be positive. Correct? So negative number, positive number, answer choice B is the correct answer. So there are again 2 ways of doing this question. Okay, question number 5. The altitude of triangle PQR from Q. Okay, so from Q I draw an altitude, basically a perpendicular. What do I get? This is an isosceles triangle, 10, 10, two sides are equal. That means this altitude is going to divide this angle. Basically, this is going to be a symmetric figure. Okay, these are also going to be same, these bases. So that's mean they're going to be 6 and 6. Okay, these angles are also going to be the same. This angle obviously will also be the same. Okay, so this is 6 and 6. So if I look at one triangle, I have this 90 degree. This is an altitude, so this is 90 degree, right? So this base is 6. This is hypotenuse is 10. So this has to be 8. Pythagorean triangle, right? 6 square 36 plus 8 square 64 is 100. Root of that would be 10. Correct? We have covered that. This is a very typical 6, 8, 10, very typical Pythagorean triangle. Okay. So the height basically comes out to be 8. That's the point. So this is 8 units. This is 6 units. Answer choice B. Oh, sorry. Answer choice A is the correct answer choice. Okay. I almost did a silly mistake. Answer choice 8 is the correct answer. Okay. Question 6. PQRS is a square. All right. So this is all equal length. So x plus 1 equals y plus 2. Right? That means x is going to be y plus 1. X is a bigger number, y is a smaller number. X is a bigger number, y is a smaller number. Answer choice A. Correct? And this will work with any numbers. If you want, you can also take let's say this is unit is 3 units, 3 3 3 3, so this y is going to be 1, x is going to be 2. You can also verify it by taking some numbers. Okay, question 7, x is greater than 1. All right, so I'll take x as 2, and I multiply these numbers. Okay, uh, let's do it there again. You can do it algebra way. Let's do it the simple way by taking a number. X is equal to 2, so x plus 5 is 7, 2x is 4, 4 plus 3 is 7, 7 into 7 is 49. Okay, here x plus 3 is going to be 5, 2x is going to be 4, 4 plus 5 is going to be 9, so 9 times 5 is going to be 45, right? So 49 is bigger than 45, answer choice A. I can take some other number also and verify, but let me do it completely differently by expanding these expressions. Okay, so let's say if I expand this, x into 2x plus 3, so that is 2x square plus 3x, and plus 5 into 2x plus 3 plus 10x plus 50. Okay, so what do I get? I get 2x square plus 13x plus 15. That's what I get here. What do I get here? X into 2x plus 5, so that is 2x square plus 5x, plus 3 into 2x plus 5, so that is 6x plus 50, right? So that what do I get? 2x square plus 11x plus 50. Okay, so if you compare these two expressions, you will realize that this is 13x, this is 11x. So essentially the question is 13x bigger than 11x when x is greater than 1? If x is a positive number, 13x is going to be greater than 11x. Correct? That's what we saw here also. So again, algebra wise also, you can prove that this quantity will be bigger than this quantity. Answer choice. All right, let's look at question 8. X is greater than 0. All right, uh, x by 14, 14 by x. How do I do that? Let's take a number. Let's say 14. Let's take easy numbers. X is equal to 14. What do I get? X is equal to 14. This comes out to be 14 by 14. That is 1. 14 by 14. That is 1. So answer comes out to be C. But again, that's going to be an easy case, right? Because everything got cancelled. Here, let's pick some number. Other number. X is 7. When I say x is 7, I get 7 by 15, so I get 0.5, and here I get 14 by 7, I get 2, right? So again the answer is going to be changing. Answer again B. If I take a bigger number, right, 140, here I'm going to get 10, and here I'm going to get 0.1. So their answer would be A. So you would realize that you are not getting a consistent answer. The answer has to be answer choice D. Correct? There's another way to do this. Whenever we have to compare two fractions, right, how do we do that? Essentially we cross multiply. So x by 14 and 14 by x, if you cross multiply, you get x square, and here you get 14 square, right? So essentially the question is, which is bigger? Is x square bigger or 14 square bigger? We don't have any information about x. X could be 1. In that case, 14 square is going to be bigger. X could be 1 million, in which case obviously x square is going to be bigger. So you don't get a consistent answer. Answer choice D. So you could do it that way also. Let's move on. Question number 9. The largest circular tabletop, okay, that can be cut from a certain square piece of wood. Okay, so we have square piece of wood. I want to cut the largest tabletop. That's going to be like this, right? So the circle has to touch the sides of the square. Uh, the largest circular tabletop that can be cut from a certain square piece of wood has a circumference of 105 pi inches. Okay, so let's say uh, if the radius of the circle was r, the square would have to have 2r as the side, correct? And what they are basically saying is that circumference of this circle, which is 2 pi r, is 105 pi. Okay, so 2r is going to be 105. So this is basically 105 inches long. That's what they're saying. Okay, I got this part. Now let's look at the question. The length of a side of the piece of wood before the tabletop is cut from it. What is the length of the side? Length of the side is 105 inches. And what do I have here is 105 pi inches. Okay, don't miss this pi. It's 105 pi, which is going to be 105 into 3.14. Okay. So this is 105, just 105. This is 105 multiplied by 3.14. So this quantity is going to be bigger. Answer choice B. Right. See, math wise, this question is fairly straightforward. What I sort of liked in this question is it's a little complicated to read. You have to be very careful in reading this. Otherwise, also this pi thing, if you miss that, you might just mark C as the answer, right? So be very careful. Time and again, we have seen that. Okay, question 10, 10 raised to 20 is equal to 10 raised to 100 divided by 10 raised to n. Okay, whenever we have an expression like this, for example, a raised to b by a raised to c, right? What do we do? What does this basically mean? It means a into a into a b number of times, right? Divided by a into a into a c number of times. Okay. So if b is greater than c, let's assume that. Let's look at that. So that means I have more a terms in the numerator, less a term, fewer a terms in the denominator. I can cancel them out, right? How many of them will I cancel out? I'll cancel out c of them. So how many will remain? B minus c will remain, right? So essentially the answer comes out to be a raised to b by a raised to c is equal to a raised to b minus c, correct? Even if b is smaller than c, you can still use the formula, just that this exponent will be negative. What that basically means that there are extra terms in the denominator. Okay, let's say if there was only 2a in the numerator, 3 a's in the denominator, that would mean a raised to 2 by a raised to 3, which would mean a raised to 2 minus 3 minus 1. Basically, a raised to minus 1 means 1 by a. Here also it means the same. Okay, so the formula remains. Essentially what this can be rewritten as is 10 raised to 20 is equal to 10 raised to 100 minus n. That means 20 is 100 minus n. N has to be 80. Correct? This is 80. This is 5. Answer choice A. Clear? Okay, let's move on. Question number 11. Maria's weekly net salary of 585. So she's getting net as 585 is 65% of her gross salary. Okay, so gross salary is basically pre-tax, net salary is post-tax. So there is 35% tax on that, 65% she is getting in hand. So 585, okay, let me just do it here. 585 is 65% of her gross salary, and I have to compare gross salary with 900. Okay, now here I will have to do G is equal to 100 into 585 divided by 65. Okay, this is a little tough to do. It might be a little tough for some people, right? So but this is basically going to be, if you just take a closer look, you will realize that 9 times 65 is 585. See, the numbers are always carefully chosen, so it's not going to be all that difficult. So you will get that gross salary is 900. You could also do it the other way around. Let's say, because we have 900 in column B, we could also say, okay, let's assume I don't want to do, let's say, this calculation. Okay, so let me work it out by the reference number which is in column B. If the gross salary was 900 and she has to pay 65%, I mean she gets only 65% in hand, what would that number be? Divided by 100, of course. Okay, well, because 65 is in percent, so basically it comes out to be 65 into 9. You will realize that 585 is what she gets in hand, which is the same thing here. So answer choice C. You could have done reverse calculation and then compare that with 585 instead of taking 585 and then finding out the gross salary. So just a calculation tip that you can also work reverse way. Question 12, the number of different positive divisors of 12, okay, and number of different positive divisors of 50. Okay, so this will have to work out. Let's say 12 is how many divisors are there for 12? Okay, I can divide it by 1, I can divide it by 2, I can divide it by 3, 4, I can't do it by 5, I can divide by 6, 7, 8, 9, 10, 11, 12. Okay, so 1, 2, 3, 4, 5, 6. I get 6 different, right? Let's do the same for 50. See how generally you don't have to count all the way till 50. You just have to count till 25, because after 25 there is not going to be any number that will be divisor of 50, correct? Because 50 by 2 is 25, right? So let's do it that way. 1, 2, I don't have 3, I don't have 4, I don't have 5, I have 6, 7, 8, 9, no, we have 10, 11, 12, 13, 14, 15, 16, 17, no, we don't have anything. We have directly 25, we have directly 50. Okay, so the number is big, but the number of divisors again is the same, 6 and 6. Answer choice C. Okay, now there is one more concept here that you can use. This is a little advanced, but this is very interesting. Let me just clear out some of these calculations and I'll explain what you could do if this number was sort of a big number. Okay, then this method that we just saw is going to be little prone to error, right? Because you are counting. Instead of that, we could also do it logically. How do we write 12? I write 12 as 2 into, I'm doing prime factorization. 2 into 2 into 3, right? That is 2 raised to 2 into 3. How do I write 50? 50 is 2 into 5 into 5, correct? Prime factorization, 2 into 5 square. So you get it down, these numbers, in the form of their prime factors, okay? And what you do is number of factors of that, basically how many divisors these numbers will have, will always going to be right in. So here we have two prime numbers, their powers are 2 and 1, correct? Just add 1 to each. So 2 becomes 2 plus 1, 1 becomes 1 plus 1, okay, and multiply. So you get 3 into 2, 6. Got it? I took the power of 2 plus 1, took the power of 3 plus 1, multiply. If there were more prime numbers, I would have continued to do the same. So here also I get, what are the powers? 1 and 2, right? What is that number in the bottom? What is the prime number? That doesn't matter. I'm looking at the power. Okay, so what do I get here? 1 plus 1 into 2 plus 1, again 2 into 3, 6, right? You could do it with, for practice, you could do it with other numbers also. So it's basically how many prime factors and in what powers I have, right? That way, even if it was a very big number, I could have just directly done it from here without having to calculate, because there you're likely to make a mistake. See, look at these jumps here, 10 to 25, right? If you're going to calculate, verify for each number, that's going to take a long time and you're also likely to do mistake. Instead of that, follow this method if you understand this. Okay, all right, that's question number 12. Okay, let's get rid of some of these calculations here. Okay, question 13, x minus y is not equal to 0. That means x is not equal to y. Okay, they have x minus y in the denominator, that's why they have given this. All right, but x could be bigger, y could be bigger, I don't know that. I have to compare these three. Okay, I can take some numbers, right? Always think about taking numbers. Let's say I take 1 and 1. Okay, I can take 1 minus 1 and 1, because otherwise x minus y would be 0. Let's say I take 1 comma 0. Let's make it even easier. So 3x square is going to be 3 minus 3y square is going to be 0. X minus y is going to be 1. So I get 3 here. 3x minus y, 3x minus y is 3. So I get answer as C. All right. Let me take some other numbers. Let me take some numbers where let me take this combination. Why am I taking this combination? Because x minus y is not equal to 0, but I still don't know whether x is bigger or y is bigger. Okay. So let me first see if I'm able to get some consistent answer. If I'm not able to get consistent answer, then obviously the answer choice becomes D. Okay, so 0, 1. If I still get a consistent answer here also in this case, then I'll probably try with negative numbers or something. So 0, 1, let me see 0, 1, let me do it in a different color. 3x square is going to be 0 minus 3y square is going to be 1, sorry, 3 divided by 0 minus 1. So that's minus 1. So I get 3 here and 3 times x minus y. X minus y is going to be minus 1. So I get minus 3 here. Okay. All right. So now I'm getting A as the answer. I'm getting different possibilities. I'm getting C as an answer in one case, A as an answer in one case. The correct answer has to be D. Correct? Now there is one more way of doing this. Algebra. Simple. 3x square minus 3y square. So let me simplify this. I take 3 common. What do I get? X square minus y square divided by x minus y. I write that as x square minus y square. I write it as x plus y into x minus y divided by x minus y. Okay. Now, very likely you might just cancel this x minus y out. Okay, but remember that whenever we cancel x minus y, we don't know whether x minus y is positive or negative, right? If you look at it this way, x minus y, right? We don't know x minus y is positive or negative. If this was positive, if we knew this was positive, we would have cancelled it out, right? But we don't know, so we can't simplify it any further. Okay, so that basically would mean if x is positive, then only I can compare. Doesn't help me. I think this is a little tricky to do it with algebra. Okay. At that point, if I had started with algebra, I would have realized that there are these complications. Let me just simply pick numbers. And then I would have again come back to this. Okay. So again, it depends on your familiarity, your way of thinking, which method you would like to try first, right? So it just depends on that. Eventually you will get the same answer. It's not that this, just that sometimes you get in the you follow a wrong direction and then you realize this doesn't go anywhere. That happens with me also, like it happened now. That's fine, that happens. All right, question 14. 3 into 3 into n. All right, that is 9n is equal to 4 2 into 2 into p, 4p. Okay, n p is not equal to 0. That means none of them is 0. Neither of them is 0 rather. Okay, so n by p, I need to get n by p. So n by p has to be 4 by 9, correct? 4 by 9. Okay, so this is 4 by 9, this is 2 by 3. If I want to make everything into 9, I would have to multiply by 3 both sides. So this is going to be 6 by 9. Okay, so this is 4 by 9, this is 6 by 9. Both positive numbers, bigger numerator, bigger number. Answer choice B. Okay. All right, x and y, I need to compare these angles. This is a parallelogram. So these are parallelogram. The only information I have is these lines are parallel. So if this is y, this is y. Sorry, this is y. Okay. If this is x, this is x. Right. What that basically means is that x plus y plus this number same as x plus y plus this number. So these angles are, these opposite angles are equal. This is also x plus y, this is also x plus y, these are also equal. All right, but which one is bigger? That's the question, right? X is bigger or y is bigger? I don't know. I mean, they could be equal also, right? If there were, if these like for example, if this length was equal as this length, they could be equal. This is bigger, then one angle will be bigger. I don't know. Let me just try to reconstruct it in the form of a square. Okay, okay, I think this doesn't look like a square. Let me take one specific case of this. The specific case of this would be a square, right? In that case, x and y are both 45 degrees, so answer would be C. But if I take a long rectangle like this, right, then obviously one angle is going to be different. I don't know which angle, right? If I take a vertical rectangle, that's going to be a different angle again. So I'm not going to get a consistent answer even when I'm thinking about only squares and rectangles. Okay, so I'm thinking about parallelogram when I'm looking at not having any angle as 90 degrees, right? It's all going to even, the situation is going to be, the number of cases are going to be even more. I will not be able to compare. So answer choice D is the correct answer. All right. Okay, let's look at question 16. If x 8x minus 3y is equal to 24, okay, and y is equal to 0. Oh, all right. Y is equal to 0, so this number is going to be 0. So 8x is equal to 24. X is going to be 3. What are they asking? Okay, x is equal to what? X is equal to 3. Answer choice A. Very easy question. 17. If the sum of 3, 7, x is 18. Okay, so 3 plus 7 plus x is 18. Oh, sorry, this is plus x is 18. Then the average of 3, 7 and x is going to be, average is going to be 3 plus 7 plus x divided by 3. That means 18 divided by 3. Average is going to be 6. Okay. If you want to find out x, you could do that also. Just based on this information, you get 3 plus 7 plus x is equal to 18. So x is going to be 10 plus, this side we have 10, we have 18 here. X is going to be 8, right? But that doesn't help you. They are not asking for that also. Okay, they are asking for the arithmetic mean. And then you would do the same thing. You would add 3 plus 8 plus 3 plus 7 plus 8. Again, 18 you will get, divided by 3, 6. Right. Question 18. If n is equal to 3, then what is the value of 2 raised to 2n plus 1? Look at where this plus 1 is. It's not 2 raised to 2n plus 1. It's not this. It's 2 raised to 2n. Whatever number comes, add 1 to that. Okay, so be careful. So it's this expression. So 2 raised to 2n is, if n is equal to 2, is going to 2 raised to 6. Take that number plus 1. So what is 2 raised to 6? It's 2 to 2. Sorry, 2 to 2. That's 8. Right, and again 2 to 2 multiplication, that's 8. So it's going to be 64. 64 plus 1 is 65. Answer choice. Keep all these 2 raised to at least till 7, 8, 3 raised to 5, till that point. Try to remember all these numbers so that you can quickly spot any patterns. Okay, in the figure, what is x? This is x, this is x, and this is 30. If I add them up, I should get 180. So that is 2x plus 30 is 180, right? So that is 2x is 150. X has to be 75. Answer choice D. Generally, these question number 20, 16 to 20 are very straightforward. Generally, okay. Obviously, this is old format GRE, so this tip doesn't help you. But what I've seen while solving these big book tests is that question number 16 onwards for the next 5 questions are fairly straightforward. Question 20, 3 individuals contributed $800 each towards purchase of a computer. Okay, so they got 800 times 3, so they got $2,400 with them. If they bought the computer on sale for 1950 plus 10% sales tax, okay, so 1950 plus 10% is going to be 195, correct? The 1950 plus 195, that's going to be 2145. Okay. Then how much money should be refunded to each individual? Okay, so they collected 800 each, so that is 2400. The computer actually cost them this much. So how much are they left with? Minus this, right? 2400 minus 2145. So that is 55 $255. It has to be divided equally, correct? So 255 by 3 would be 85. $85 should be refunded. Answer choice B. You could have also done it this way. You take this number, okay, 2145, divided that by 3. That is how everyone should pay. right? So that would be 7 and 15. 715 is their cost per head. They have paid 800. So how much should they get refunded? 85. Answer would anyway come out to be the same. Okay, so let's look at the interesting questions. Those are the graph ones. Graph questions 21 to 25. National health expenditure 1960 to 1978. Okay, I don't know. Most of the big book questions seem to be about health expenditures only. We have done one similar set previously also. Uh, Maybe they find it easy to create questions like this. Or maybe the data was available, whatever. Anyway, it doesn't matter. So national health expenditure in all these years, this is health expenditure, billions of dollars, all right. Total health is given in this, all right. Private and public. So private, public, we have done something similar in another test also, just that there it was percentages. Here there are absolute numbers, but anyway, public and private should add up, right? So let's see, this is 20 plus, I don't know, 10 something. Yeah, so that comes out with 30. This is 200, which should be a sum of 120 and 80, correct, right? So these two lower graphs add up to this bigger graph, bigger line basically. Okay, for all these years. Makes sense? Total health expenditure as a percentage of gross national product. Okay, so this is the total health expenditure. For example, in 1978, $200 billion was total health expenditure, which was what, 9.88, 9.9% of the whole GDP. Okay, fine. That's what it is. Okay, is there any other graph? No. Fairly straightforward. Understood both graphs. Let's look at question 21. In 1969, approximately what was the amount of private health expenditures? So 1969 private, absolute number. Okay, 1969 private. Private is this big dotted. 1969 private. What was the number? It must have been something like 45, something like that. Okay, it's very difficult to see that, but the answer choices are going to be equally uh, spread out, right? So 45, correct, 45 billion. Answer choice C. They are not going to be very close answer choices here. Question 22, for the years shown, what was the first year in which the amount of public health expenditure was at least $30 billion? So I want public health to be at least 30. The first year in that it was at least 30. That means it was more than 30. But what is that, public or private? Be careful, public. Okay, so I want public to be greater than 30 for the first year. What is that first year? Where is public? Public is this. So I'm looking at this. Where does it go more than 30? More than 30 means has to cross 30, right? Here, if you look at this closely, this is not crossing, this is crossing here, right? This is kind of in the middle. Okay, so it has to be 69 or 70. Let me see. Uh, okay, let me just clear this out just so that we get a clear, much clearer view. Okay, uh, 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 so I'm confused between this number and this number, this number and this number. So this number is closer to 20 than 30, right? So it has to be 1970. All right, 1970, 1970, right? Okay. Even if you could not see it, or maybe on the video you're not able to tell the difference, but 1969 is not there in the answer choices anyway, so it has to be 1970. Okay, question 23, 1976, approximately what was the ratio of the amount of private health expenditure to the amount of public health? So I want private by public for 1976. Very straightforward. Let's look at this. Private versus public. So this is private. Let's first find out private. Private is this graph. 1976 private was uh, somewhere in the middle, 90. 1976 public was slightly more than 60. Okay, so let's say for the sake of simplicity 60. So the ratio would come out to be somewhere close to 3 is to 2. Okay, 3 is to 2. There is no other ratio close to 3 is to 2. 3 is to 2 is given approximately. They will accept this answer, right? There is no other close answer. Okay, question 24. For the year in which year this happened, we'll have to first find that out. for the year in which public health expenditure was closest to 400 billion. Let me just pause here. Let me just find out what year this is so that I don't get lost in this information. Public health expenditure closest to 40 billion. What is that year? Public, that is, oh, okay. Always verify public or private. Okay, this is public, has to be close to 40. That means this graph has to be close to 40. That is this year, 1973. So basically what there's the question becomes, in 1973 the total health expenditure was approximately what percent of the GDP, gross national product. Okay, the total health was what percent of gross national product, that is given in this graph now. Okay, so but what was the year? 1973. So 1973 total health was what percent? Somewhere like a 9 point something, 9.1, 9.2, something like that. Okay, maybe 9. Yes, answer choice B. Okay, let's look at question 25. Approximately what was the amount of GNP in 1968? Now I don't have the amount of GNP anywhere, but I know GNP as the total health expenditure as the percent of GNP. Okay, so let's do that. 1968. What can I say about 1968? I can say 1968. What is this number? Uh, this number is, I don't know, somewhere like 7%. Let's take 7%. Okay, 7% of GNP 1968 happened to be 1968 total expenditure is what? This. Again, I'm not very comfortable with this number, whether it is 65 or 70. uh, I don't know, right? uh, 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 let's say for the sake of simplicity I say take 70 billion. So basically what I have is 7% of GNP in that year was 70%, but was 100% of GNP. Okay, so that is going to be 70 billion divided by 7 into 100. Correct. So that is 10 billion into 100, somewhere around 1000 billion. Okay, somewhere close to that. Let's see if the answer choices are like that. Okay, I have one answer choice here. I'm tempted to tick this one. Let me just verify if this was indeed 950 billion. Okay, because I'm not able to get any close numbers, right? If it was 950 billion, so based on this number, this which is 7% or so, what would have I got? 950 billion into 7%. Okay, so that is what? 0.07 actually, right? Anyway, so the decimals will take care of later. So that will be 0, 5, 3, 66, and it will be 66 billion, 66.50. Okay, something like that. Is that matching up with this 66.5? Yes, it is matching up. But let me also verify this just to be doubly sure, because this number is also very close. If it was 800 billion, then that would have been 800 billion into 0.07. That would be 0056. Okay, 56. Okay, right. It is definitely not 56 because it's definitely above 60. Okay, so now I have some confidence to say that okay, this answer choice doesn't make sense, right? But otherwise, the way these answer choices are, is very likely that you can end up making an estimation error here. Okay, not a fond of this type of questions, definitely. And again, you are not likely to get this kind of question here on the GRE, and you are GRE because these are old tests, and there is a lot of you know printing printing errors or visibility issues while scanning these PDFs, those kind of things that are coming at play here. It's not a GRE difficulty per se. Even if you get this question wrong for because of estimation, don't really worry about it. Okay. Question 26, if x and y are integers and x greater than y greater than 0, okay, so let's say 3 greater than 2 greater than 0, how many integers are there between but not including x and y? Okay, so I have this number line, I have 2 here, I have 3 here. How many integers are there in between? Excluding, I'm not taking 2, I'm not taking 3. Then how many integers are there between? 0 integers. Okay. So if x is equal to 3, y is equal to 2, I should get 0 as an answer. Where am I getting 0 as an answer? Here 3 minus 2 is 1. So that's not the answer. Here 3 plus y, x plus y would be 5. That's not an answer. X minus y, that is 1 minus 1, 0. Yes, I'm getting 0 here. So this is a good answer. Let me keep this. X plus y minus 1, that's going to be 5 minus 1, 4. That's not the answer. X minus y plus 1, that is 1 plus 1, 2. That's also not the answer. So the correct answer is going to be C. Okay. You can also do it logically. Let's say if this is x, this is y, right? Let's say there are two integers. How many integers are there? These many integers. But what does this 2 mean? It means that 1, 2 and 3. If there is a difference of 3, there are 2 integers. If there is a difference of 4, there are 3 integers. Basically, there is one integer less than the difference, which is what this also says. This is the difference, this is minus 1, right? So logically also you could do it. It's easier to do with some numbers, because then possibility of error is less. Question 27, for which of the following expressions would the value be less? Okay, I want to reduce this value. If 350 were replaced by 347. Okay, so I want to replace 350 by 347. That means I'm going to replace it by a smaller number. Then which expression will give me a smaller value, right? So here I have fixed number. If I compare that with this 3500 minus 347, which number will be bigger? This number will be bigger, right? Why? Because if I compare these two, I'm subtracting a smaller number. If I'm subtracting a smaller number, the result will be bigger. So this, but I want a smaller result. So this doesn't help me, correct? You could also do the math and do it, but I'm telling logically. 1 by 130, sorry, 1 by 350. If I compare that with 1 by 347, right? Numerator is the same. That means bigger the denominator, smaller the number. So this number is going to be small. This number is going to be big. Value in fact goes up. I want it to go down. So this also doesn't help me. Okay. Now let's look at this. This seems little confusing. Let's look at this. 1 by 1 plus 1 by 350 compared with 1 by 1 plus 1 by 347. So we just now saw that this number and this number, which is there in answer choice B, this number is smaller and this number is bigger. Correct. So let me just write it like this. 1 by 1 plus small number, 1 by 1 plus big number. Okay. What is bigger? 1 plus small number is bigger or 1 plus big number is bigger? Obviously 1 plus big number is bigger. But that's in the denominator. So basically I'm saying here I have 1 by something small. Here I have 1 by something big. Now is the value decreasing or increasing? 1 by something small is big. 1 by something big is small. So I'm going from big value to small value, right? So that means value is reducing. Here it makes sense. So answer has to be 3 only. Okay. Don't really worry about this 350, 347. No one is asking you to do any calculations with these big numbers. Okay. Obviously, no one is asking you to calculate this. But yes, it's purely logical. We have done something similar last time where the question was not like plus or something, but it was something like a by b divided by d by e or something like that. It was one of the last questions in the previous set, test 4, whatever that section was, right? Just the previous video. And there they were also asking what would happen to this whole thing. I want to reduce this whole thing. What should I increase? It was something similar, just that there the logic was in you had to figure out, we don't have to do any calculation, but you have to figure out what number would reduce. So we basically, you need to increase the number in the denominator. That was the logic here. Okay. Something similar here at play. Question 28, if the circumference of a circle P is 15.71 4, and circumference of circle Q is 6.28. 6.28 is basically twice of 3.14. Okay, that's easy to catch. So uh, that's good to note, because then somewhere pi and pi will get cancelled. Then the diameter of P minus diameter of Q is what? Okay, let's first find out diameter of P. The P is a circumference of that is what? 2 pi r. 2 pi r, let's see, capital R is equal to 15.71. Okay, 15.714, and for Q it is 2 pi r is equal to 6.28. Okay, so like I said, 6.28 is twice of 3.14, so that means 2r is equal to 2, r is going to be equal to 1. Correct? Okay, r is going to be equal to 1. Same thing, maybe this is also a multiple of 3.14. Let me find that out. 15.715 divided by 3.14. I'll start with a 5. Okay, let me see if that works out. 3.14 times 5 is going to be 15.7 something. Okay, so this is going to be 5 pi roughly. Okay, see, all these are all rounding errors, and pi is obviously an infinite number, so that's why we are getting. So basically this is 5 pi. This is 5 pi. Okay, so basically 2 pi r is 5 pi. Pi gets cancelled. The diameter 2 pi is 5 units. Here the diameter is, radius is 2 minutes, so diameter is 3. Diameter is 2. Okay, and what are they asking? Minus. That's the difference. So 5 minus 2 is 3 units. That's the answer, right? Uh, this requires you to spot that these are multiples of pi. Otherwise, you will just end up doing large calculations. You will still get the correct number, right? But it's just so much easier if you spot that these are multiples of pi. Again, a slightly tricky question. Question 29. According to the number line above, which of the following points has a coordinate most nearly equal to P into R? Okay, so what is P? Again, I'll have to assume some number. This is looks like 0.8 or 0.75. Let me say it is 0.8 because my calculation will become easy. What is R? R is, if this is 3.5, this is 3.75 or something. Okay, 3.8, something like that. Okay. So let's say 3.8 into 8, so that is 38 into 8. Let's see, what do I get? 4, 6 as carry, 30, 3.04, somewhere close to 3. Okay, now I don't have a number that's more than 3 but close to 3. But again, this could be this could have really been 0.75. This could have been 3.75. Okay, let me do a calculation with 3.75 also. 0.75. Okay, this will require me to do some calculation, but this is 0.75, right? So basically divide by 4. Divide by 4, multiply by 3. That logic I can use. So let me divide this by 4 and multiply by 3. So this is, if I do that calculation, what is 25%? It's going to be 0.950. Correct? Okay, let me just do it simply. Okay, let me not worry about the decimal. Let me just do 75% of 38. Let me do it that. So 38, 50% of that is going to be 19. 25% of that is going to be 9.5. So 75 is going to be 38 minus 9.5, which is going to be 28.5. Correct? 28.5. Correct. So this number basically will come out to be 2.85 in that case. Okay. So somewhere around 3, based on what these actual numbers are. Okay. That is, answer has to be C, because the other numbers are like very big as 3.5, or other closest number is 2. The answer has to be C. Okay. Again, this is in this set. This is the second time that I am having to do some estimation that's not exact. I mean, obviously estimations are never exact, but the ballparks are really rough here. Okay, like we saw in the graph question also. But yeah, this can happen. That's purely because these are old tests and these are scanned copies of printed material. All right, let's look at the last question now. Question 30. A rectangular rug covers half of a rectangular floor, that is 9 by 12. Okay, so let's say this is 9, this is 12, this is 9, this is 12. This is covering half. It could be this way or it could be this way also. Okay, which half I don't know. If the dimensions of the rug are in the same ratio as those of the floor. Okay, interesting. So they are saying the dimensions of the rug are also 3:4 only. So that means the rug has to be exactly in the middle. It doesn't have to be in the middle, somewhere in the of this shape, ideally in the middle, but it could be anywhere actually. Just that for an easy case, let's say assume that this is in the middle. Okay, even if you move this, the area of the rug remains the same, the overall area also remains the same, so the difference is also going to remain the same, right? The difference is half, right? Because it's covering half of the area. Okay, all right. How long, how many feet long is the rug? Okay, so basically they are asking us to find out the dimensions of the rug. So let's say the dimensions of the rug are, this has to be 3 by 4 now, so 3x by 4x. Okay, the rug is going to be in that case 12x square as the area of the rug. Okay, which is half of area of the rectangle. Correct. Area of the rug into 2 is equal to area of the rectangle. Okay, fairly easy now. 12 gets cancelled. X square is equal to 9 by 2. Okay, so the x is 3 by root 2. Weird. Okay, but let's see, what are they asking? They are asking me for the length. Length is 4x. Okay, okay, so 3 by root 2 into 4 times, right? So this root 2 will become 2 root 2, right? Root 2, so that means 6 root 2. All right, 6 root 2 is the answer. Okay, uh, the calculation is a little tricky because of the root 2 and everything, but yeah, 6 root 2 is the only answer. What you could also do is you can verify if this 6 root 2 is the length, the what would be the width, what would be the area of the rug then, and verify that area of the rug is half of the rectangle. Okay, you can do it for your own clarity, but the answer is going to be 6. All right, so that was the set. I found this set to be not so great in terms of the clarity of the paper and everything, because there were a couple of questions that required us to go back and forth to verify the numbers and everything. So that was not a very that whole experience didn't really add much value to GRE preparation as such. But yeah, I mean, when you are dealing with old material, that happens. But otherwise, in terms of difficulty, I think this was pretty straightforward in terms of the type of questions that you get on the GRE. This was not very different from any of the previous questions except those two data type questions, right? So I hope you have been solving. Again, I keep saying that. Hope you have been solving. If there is any question that you struggled with, if there is any sort of unique insight, unique comment that you like to put on the video, or you're welcome to do that, please do that. Also, if you like this content, uh, please subscribe to this channel. We'll be coming up with, I think this is what for. We still have more 45 videos in this series, so I'm working hard towards that. And also, otherwise, also if you want any specific type of content to be covered, please let us know, and I'll do my best to create videos and on that. All right, so on that note, happy GRE.